In this video we're going to be going over Theorem 2.001. It says that there exists a triangle with angle sum less than 180. So we're not proving that every triangle inside hyperbolic geometry has an angle sum less than 180. We're just saying, hey, it's out there, it exists. In a later video, we'll actually prove that all of them do, but for this one, we're just proving existence. And it's going to be quite a long proof, so leave yourself plenty of space if you're writing this down. Let's say proof. I'm going to try to do this as quickly as possible. We'll say let L be a line, let B be a point on L such that, actually it can be any point on L. Then we'll say construct a perpendicular to L at point B. And let A be a point on this perpendicular. So let's see what we have so far. This is going to be quite a large drawing in the end. So we'll have this line L. We have some kind of point B here. Actually, we should have said such that A is not equal to B. That's important. Then we'll have this point A up here. And we'll say let M be a line through A perpendicular to AB. So we have this line M that goes through A and it's perpendicular to AB. Then by a previous theorem, M is parallel to L. And by our hyperbolic parallel axiom, there exists a line N where N does not equal M, and A is on N, and N is parallel to L. So we'll call this right. Let's do N in green just to make everything easier to see. So we will use, we don't need to go over that. We can skip that small part of the proof. So we'll say let C be a point on L such that B does not equal C. So we'll put C, let's put it right here. And we'll construct AC and let gamma equal a measure of angle BCA. So we have gamma right here. And by extendability, we extend BC to the point C sub 1 such that that length from C to C sub 1 is equal to AC. So I know drawing-wise this doesn't work out, but we're gonna go with it anyways, because drawing this properly would take even more room than it's already going to. So then we'll say let gamma sub 1 equal angle C sub 1 A. So gamma sub 1 is right down there. Then by the isosceles triangle theorem, isosceles, I think that's a C there in isosceles, isosceles triangle theorem, measure of angle CA C sub 1 equals gamma sub 1. And by the strong exterior angle inequality, gamma is greater than or equal to gamma sub 1 plus gamma sub 1, which means gamma is greater than or equal to 2 gamma sub 1. So we can continue this by this theorem by repeating the same thing over and over. We'll extend. That's not the color I meant to have. We'll extend this line that we just made to C sub 2 such that C sub 1, C sub 2 is equal to AC. And we'll say let gamma sub 2 equal the measure of angle C sub 1, C sub 2, A. So we have now extended it to this point here, which we'll call C sub 2, and this is gamma sub 2. And that's the wrong kind of yellow. We'll say, then, as before, using the strong exterior angle inequality, we have gamma sub 1 is greater than or equal to 2 gamma sub 2. Or we can also write that as gamma sub 2, just gives in some basic algebra, is less than or equal to gamma sub 1 over 2. But gamma sub 1 this is a contradiction because gamma sub 1, well, this isn't quite a contradiction yet, but gamma sub 1 is less than or equal to gamma over 2. So then we obtain gamma sub 2 is less than or equal to gamma over 2 and all that over 2. Or we can also put that as gamma sub 2 is less than or equal to gamma divided by 2 squared. In general, we can obtain the angle gamma sub n such that gamma sub n is less than or equal to gamma divided by 2 to the n. So that allows us to get an infinitely small angle there. And we'll say choose n such that gamma divided by 2 to the n is less than delta. And we'll label delta here as, let's see, where do we want delta? We'll say right here is 90 degrees, and we'll put delta right in here. So we then have gamma sub n is less than delta, and measure of angle C sub n is less than delta. I need to copy this and move this to a different place so we can keep using it. That's not the one right here is where I want to copy. Let's put that right there. Okay, back to the proof. So we shall show that the angle sum of triangle A, B, C sub n is less than 180. And that's what we're trying to do. We'll make a claim that measure of angle BAC, well, BAC sub n, is less than 90 minus delta. Suppose that's not true. Suppose measure of angle BAC sub n is equal to 90 minus delta. Well, then we would have n is equal to AC sub n. But that's a contradiction, because n is parallel to L, and AC sub n is not parallel to L sub 1. We'll say that suppose measure of angle BAC sub n is greater than 90 minus delta. So we ran into a contradiction when we assumed they were equal. Now we'll assume it's greater than. You can say that then, well, I need a point D out here. We'll call somewhere on here point D. Anyways, then D is in the interior of angle BAC sub n, and by the crossbar theorem, the ray AD intersects L. That is, N intersects L. But that's a contradiction because N is parallel to L. And once again, we need to move on. So we'll take our drawing with us. Therefore, M is less than, M is the measure of angle BAC sub n is less than 90 minus delta. We ran into contradictions whenever we thought it was greater than or whenever we tried to assume it was equal to. So then, measure of angle BAC sub n plus measure of angle B plus measure of angle C sub n is less than 90 minus delta plus 90 plus delta, and all that equals 180. So measure of angle BAC sub n plus measure of angle B plus measure of angle C sub n is less than 180 degrees. And we're finally done.